Hi there, welcome back again to the Ivory Tower Collections. I just wanted to show you something kind of cool I got recently, about 2 weeks ago I guess. And it's a new diagnostic tool set, specifically for use on a Colecovision. And it is called the Diagnostic Shield. And it is designed and developed by a guy who goes by the name of ChildOfCV over at AtariAge. I'll make sure to include a link in the video description for that thread so that you can check it out. Now, the project is completely open source, as the creator of this doesn't plan on mass producing these and selling them separately. He created a kit for me to check it out and work with it. But for the most part, again, it's open source, so he just expects people to just check out the thread and download the different files and what have you that he's got so that they can develop and create their own PCBs, make changes if they wish, and make their own programming. But let's talk about the basic components needed for the Diagnostic Shield. So how does it work and what do we have here? Well, first of all, we have the main brains of the entire kit, which is this board right here. This is actually designed to plug into the expansion port on the front of the Colecovision and contains most of the main logic for the Diagnostic Shield set and programming. It also includes the secondary daughter card, which is used sort of as a loopback board, specifically to be plugged into the cartridge port. Now, my particular one here, because of how large the actual contact pins on the PCB, I was concerned about them possibly shorting against the metal door on the Colecovision. So I just as a precaution, I added some additional Kapton tape all the way around it. And then also, because the orientation of this board is important when you use it, I made sure to write on my Kapton tape which side was the front and which side was the back. And then it also has an interface cable that it comes with, or that's needed, so that the two boards can communicate with each other. There's another cable you're going to need to use this, and you know what the type of cable you need is going to depend on what you're going to connect it up to. And yes, it does have to be connected to something, and we'll get into that in a second. But you're going to need a micro USB cable to whatever other USB you need on the other end to work with it, because the way that the Diagnostic Shield works is it doesn't have any kind of an interface that we use through the Colecovision itself, because it's actually designed to help you test and diagnose a Colecovision that maybe doesn't work enough properly to actually produce a picture. This little guy can be plugged in and give you some results and do some basic diagnostics to help you isolate where the problem might be. So as a result, it actually requires the use of a separate computer, such as a laptop or even a tablet like what I'm going to use in this video, to actually communicate and interface with the main Diagnostic Shield board itself. And also, that's how the Diagnostic Shield receives its power. It doesn't rely on the power from the Colecovision, because again, that could be one of the problems, is the power not getting where it needs to on the Colecovision. So instead, it uses that micro USB connection not only to be able to talk and interface to a separate laptop or a computer, but also to help provide it with the power it needs to operate. So with that, I'm going to change the camera angle and we're going to get this thing plugged in and check it out. I now have the setup ready for us here. I've got my little tablet ready to go with the USB, in this case it's a micro USB to micro USB interface on the actual Diagnostic Shield. I also have the small loopback cartridge daughter board installed with the interface cable between those two. My Colecovision is powered on, and I'm going to see if I should be able to get a picture or a capture of my Colecovision while we're doing this right next to the screen here. So what I'm going to do is I'm going to zoom in a little bit on the actual screen for the diagnostics so that we can get a better idea on how it looks and operates. Okay, we'll see if that works. Now for starters, I have everything already connected up, and it even detects it automatically with my little terminal emulation program I'm using here. I'm not sure how well that shows up, but it says that the USB device is connected along the bottom there. And so what I'm going to do first to make sure everything's communicating is I'm just going to hit the enter key once here to bring up an interactive menu. So hopefully you can see this okay. So we have a battery of different tests that we can choose from. We have the voltages, basic functionality, memory, CPU, the VDC or the video display, a sound test, the input test, and then also the ability to send an external video and audio test both as an NTSC and as a PAL signal to the ColecoVision. Now, let's just go through the list here. We'll start with the voltages first. So if I just push 1 to select the voltages, what the ColecoVision or what the Diagnostic Shield is doing is it's actually reading the current voltage readings directly from the different voltage rails that are on the expansion port itself. It reads the -5, the +5, and the +12. So in this case, it looks like my -5 is reading around -5.16, and then my +5 is right at 4.95, and then the +12 is reading about 12.46 in this case. So this is a good way to know that your voltages, at least from the power supply you're using, are making it completely through the system and all the way back to the expansion interface board on the front of the ColecoVision. If for some reason any of these are missing, or if their values are a little too low, it actually has programming and algorithm in it to tell you that. So it would actually come up and tell you that one of your voltage readings, and it'll show you which one it is out of spec and possibly needs to be addressed and looked at. Let's take a look at the basic functionality here. So I'm going to now press option 2. Now what this will do is the Diagnostic Shield will now go through and do a couple of quick checks of some various things in the system. So as an example, it checks the clock states for both the primary and secondary clocks. Checks the reset circuit access time, or rather I should say the recovery time of it. The bus acknowledgement passes, and then it checks a couple of the main address lines. It also is doing a check along here to make sure that the cartridge port pins are also good to go. So if any of this is amiss or has an issue, it'll basically stop at that point and tell you. But in this case, everything seems to have passed and everything's good to go. So no problems there. If we go and take a look at the memory tests, it does exactly that. It goes through and it runs through a couple of different memory test patterns, checking all of the system. Well, actually it's checking the system ROM. The ROM checksum is actually the BIOS. So in this case, it detects the normal ColecoVision NTSC North American BIOS, because it says that right there. And then it goes through and it runs through the various test patterns as we can see here. And then at the end, it'll give you a pass-fail status for the RAM. Now let's take a look and run the CPU test, which is option 4. So I'm going to select that, and it's going to start and go through and quickly do a quick CPU check. And by the way, it is resetting the ColecoVision every time it does this. Now you should be able to see in the video overlay that the ColecoVision has the turn game off before inserting cartridge message, and that's because the daughter card itself does not actually contain any program code, and it's merely just a pass-through loopback device, you know, just so that the main Diagnostic Shield is able to read and get different data signals through the card itself. But again, there's no actual game programming that the ColecoVision itself understands. That's why all the interface has to be done through a separate terminal emulator through my tablet or through a PC. Okay, so back to the CPU test. So it goes through and it checks a few different things. It checks different address lines. Now, what's interesting about these address lines is that, you know, if you have the schematics available and if you have an issue, it would tell you that there was a potential issue, or it would stop at that point. So then using the combination of what you read from here and in conjunction with the schematics, you can then pinpoint or have a better idea as to perhaps a trace that's bad on the main board. You would just simply find the corresponding pin that matches the address or function being tested on the CPU in this case, and then you would trace that back to where it would go all the way back to the expansion bus. So again, it gives you a good idea of the various tests that it runs and where there might be a potential problem. And again, at the end, you get a pass-fail status. In this case, it says everything's passed. And then that takes us to the VDC test. Now, the VDC test is a little more interesting, so I'm going to go ahead and execute that right now. So it's going to do basically exactly, the first thing it's going to do is it's going to check what frequency we're running at, and since this is an NTSC North American ColecoVision, it is running at 60 Hertz, and then it starts to test all of the video memory chips using different test patterns. This test does take a little while to run, so I'll probably speed this part up. Then when it's done with the test, it'll tell you, again with a pass-fail of the actual video RAM, then it actually starts to initiate some different graphic modes to the actual ColecoVision itself. So at this point, I actually do have something on the screen that I can see. So the first thing that we see is this first test pattern here where it's doing a 1x1 without magnification. I'm going to hit the enter key to go on to the next one. This will change it over to a 1x1 with magnification. And then it goes on to the next test, which looks basically the same, only now it's a little larger sprites. And then really large sprites. And then it's going to go through this character test, which this one's kind of neat because it's alternating the backgrounds in addition to alternating between the characters and the alphanumeric. So this is checking all of your character ROM. So very cool. And then it's going to go through the same little sprite magnifications again, only this time this is through a slightly different video mode. And then it's going to do another background and graphics test between alphanumeric characters and different colors. And then here we go again with more sprite testing. This time it looks like with an inverted palette. And then we have basically just another set of character and alphanumeric testing through that video mode. And then that's it. That completes the basic video tests. So now that takes us to the sound test, which for this one, I'll have to turn the volume up a little bit so that we can potentially hear this. So yeah, I'm going to go ahead and execute the sound test, and it's going to play a series of different chords, minors and majors. Here we go. And that's it. Now you may not have been able to tell, but I was actually having to press the enter key after each of those different audio tests. Otherwise it just keeps looping the same audio test that it's currently on. So you do have to hit the enter key to advance it to the next one. Now that takes us to the input test. Now the input test, as the name would imply, is for checking the controller readouts. And this one's kind of neat because in what it's actually showing you is basically in real time, it's scanning the controller ports and scanning the activity on them. And basically these different values will change depending on what you're doing. So as an example, if I pick up controller 1 and if I move the controller up, it'll give a current read, and you'll notice that there's now a little plus symbol next to the letter N, which means north. If I push down, we now have a plus sign next to the S for south. Also keep in mind these numbers next to the side, it says 1. That's because it's indicating that all of this controller input, it's scanning from port 1. So now I'm going to move to the left, which shows a plus on the west direction, and then to the right for the east direction. Additionally, if you push the fire buttons, you'll have a little B plus that shows up indicating that the fire button was pressed on both sides. And then it will also do a read and scan of all of the different keys on the keypad. Again, it shows you with this 1 off to the far left which port it's currently reading the data from. So now if I pick up the second controller port and I immediately push up on it, you'll now see that it's changed to 2, and it now has the little plus sign next to the N for the north direction, south, west, and east. And then same thing applies. I can sit here and push the keys on player 2, and it will read all of those just as well. And then to exit this test, all I have to do is just hit the enter key when I'm done. So the last two tests are the external video audio test, an NTSC signal and as a PAL signal. So this particular test is interesting because up until now, all of the capture footage that I've had it shown up on here was through my RGB output on the Colecovision. However, these last two tests are not compatible with the RGB output and will only work through the RF or with a composite output if you have it. So that's just something to keep in mind. So as a result, I've now switched my Colecovision over to its composite output. And I'll go ahead and execute test 8 right now. Now what this will do is this will throw a test pattern up on the screen in addition to some audio. I'm going to turn that down. So there we are. It's a kind of a weird little test pattern of just some diagonal lines in this particular case. But yeah, that's basically it. Now the reason why this test is so neat is because it's bypassing most of the logic, if not all of the logic, on the ColecoVision as I understand it, and is basically injecting this tone and video signal straight into the video processor and back out through the RF modulator. Then if I do the same thing and I do 9, which is the PAL signal, now because this is an NTSC display and because this is an NTSC ColecoVision, it's not going to be in color. It's going to show you a grayscale, but you'll still hear the tone and you'll see the pattern. And there's the pattern in PAL. The interesting thing is that in RF, that's actually what the pattern looks like in NTSC. So I'm not sure why the pattern looks different through composite on mine, but either way, there it is, and it's still working, and we still have the tone. So no issues there. So yeah, pretty cool piece of kit. I like this a lot. This will actually come in quite handy and help me troubleshoot any ColecoVisions that perhaps don't even power up enough to give me a display. I can at least plug this board in, connect it up to a tablet PC or to an actual computer, what have you, and at least get some rudimentary tests done through it to at least kind of better isolate where some issues and problems might be. So yeah, again, if you're interested in perhaps getting one of these for yourself and wanting to learn more information about it, again, I highly encourage you to check out the thread that I will have linked to in the video description below at AtariAge, and maybe you'll want to reach out to the creator and the designer, ChildOfCV. Thanks again, and I will catch you guys later.